Hi friends, welcome back to our channel. In today's video, we are going to configure HSRP, that is Hot Standby Router Protocol, using IPv4 in Cisco Packet Tracer. We will be working with two routers, R1 and R2, and we will show you step by step how to assign IP addresses to interfaces, then enable HSRP with version 2, then configure priority and preemption for redundancy, and finally test how one router automatically takes over when the other fails. So by the end of this video, we will clearly understand how gateway redundancy works with HSRP, which is an important topic for real-world networking. Friends, I kindly request you to subscribe to our channel, and if you find the videos helpful, please like and share. Okay, let's get started. First of all, we will design the topology. Here we got two routers. We will choose a 4331. Then we will have two switches, 2960 series. Also two ND devices for testing purpose. We'll have PC1 and PC2. Let me rename these devices. We will connect these devices using copper straight through from S1 G0/1, R1 G0/0/0, S1 G0/2, R2 G0/0/0. Also, we'll connect our PC1 to S1. Then from R1 G0/0/1 to S2 G0/1. Then from R2 G0/0/1 to S2 G0/2. Also, PC2 will connect to FA0/1. Let me highlight our networks. So here we can see one network. Then here right side we can see the second network. Let me go to options, preferences, and we'll give always show port labels in logical workspace so that we can see where they are connected. Here we will note down the network address we are going to use in this topology. Here in this left side network we are going to use, we will use 10.10.10.0/24. Then right side we will use 10.20.20.0/24. Also, I will note the virtual address we are going to use here in this network. Virtual IP. Okay, we will use the group number 1 here. And we will use a 10.10.10.1. Okay, in the other side, here, virtual IP, we will use a group number 2, 10.20.20.1. I will keep this topology left side so that we can see our addressing table also. Now we will assign IP addresses to all the interfaces in R1 and R2. First of all, we will configure R1 CLI, enable configure terminal and we will set a host name as R1. Now IP domain lookup. Now we will go to interface G0/0/0 and we will set the IP address as per the addressing table 10.10.10.2. that is the second usable IP address. So first usable IP address already be taken for a virtual IP. Then submit to mask. Activate this interface. We can see this interface G0/0/0 is connected to our switch S1. Next we will configure interface G0/0/1 IP address 10.20.20.2. Then submit to mask. Activate this interface and we can see this interface G0/0/1 is connected to S2. So the other side. Here I will mention this is network 1 and this is network 2. So it will be easy to name it. Next we will configure R2 G0/0/0 and 1. Now enable configure terminal hostname R2 no IP domain lookup. So this is the only basic settings we do here. Then we will set the IP address as per the addressing table interface G0/0/0. We will set the IP address 10.10.10.3. Then submit to mask. Activate this interface. Then we'll go to interface G0/0/1 which is connected to S2. IP address 10.20.20.3. Then submit to mask. Activate this interface. So I expect the interface configuration is clear. This network 1 we configured with 10.10.10.0. So here we assigned dot 2. And below here we assigned 10.3. Then in the other side network 2, here we configured 10.20.20.0/24 and here for this interface G0/0/1 we configured 10.20.20.2 and here we configured 20.3. Now we will configure these end devices PC1 and PC2. Here we will set 10.10.10.10. Then submit to mask. Default gateway. So here we can see the virtual IP address we are going to use 10.10.10.1 and we can see two gateway here. So here we configured 10.2 and here we configured 10.3. So right now I am going to give one address here. Consider I'm going to give a 10.2 through R1. PC2 we will set 10.20.20.10. Then submit to mask. Then default gateway, here we will give 10.10 20.20.2. That means through R1. We will reassign this default gateway we set on this in this NG devices PC1 and PC2 after configuring our HSRP, because we are going to configure our virtual IP address. Then we will change the default gateway. Now we taken the gateway from R1 only for the testing purpose. So we can test the connectivity. We will ping from PC1 to PC2, and here we can see it is successful. We will see in the simulation mode from PC1 to PC2. We can see it goes to S1. So gateway we given R1 address. So it will go to R1, then S2, then PC2. Again from PC2 to PC1 through R1, because we configured a default gateway of R1 here in PC2. So it's successful. Just consider this R1 goes down. What happens? PC1 and PC2 will not communicate because we configured the default gateway here from this R1. So it will communicate once we reassign the default gateway of R2, so that they will communicate through R2. So here we have a redundant gateway. But reassigning this IP address to many number of NG devices, it's a tedious task. Hence, we are going to configure HSRP with the virtual IP. This same virtual IP will be configured on both devices R1 and R2. And finally, we will reassign this virtual IP as the default gateway in our NG devices. Here, PC1 and PC2. So here just I will shut down this R1. Before that, let me save from run to start. Then we are going to shut down this router, and we can see this path is closed, and we will not be able to communicate from PC1 to PC2. Here we can see it's failed. So we can make it succeed. We need to reassign the default gateway, but as I told you, reconfiguring the IP address, I mean default gateway in all the NG devices, obviously a tedious task. Okay, we are going to configure HSRP. First of all, we will configure for this network 1. Let me activate this router. Okay, and we'll fast forward. So we'll go to R1 CLI. Configuration is so simple. We need to go to the interface G0/0/0. Interface G0/0/0. And here we will give standby. We will use the version 2. We have 1 and 2. So 2 will support IPv4 and IPv6. Standby, here we will use the group number 1, then IP, and here we already given, we will use this virtual IP 10.10.10.1. Okay, perfect. Then we will give a standby 1. We will set the priority, because we are going to consider this R1 as the active router. By default, priority is 100. So we need to configure the priority above 100, so that R1 will become the active router. So here let me give 110. Okay. Also we will give a standby 1 preempt, so that when this R1 come back, he will become the active router again. Preemption. Next, in R2, we are going to enable this standby for this interface G0/0/0 for network 1. We will go to interface G0/0/0 standby version 2, standby 1. Here also we will set the same virtual IP, that is a 10.10.10.1. And also we will set a standby 1 preempt. We configured HSRP for this network 1. And here we can see we received a message, state change G0/0/0 group 1 state standby. Okay, we can verify that. We'll verify in this R2, show standby brief. So here we can see the details. So this is our R2, that is a standby router. We can see the default priority. In this router, we did not set the priority. We given only this virtual IP address and the preempt command. So by default, the priority is 100 and the state is in standby. And we can see the active router, that is a 10.10.10.2, that is our R1. And we set the virtual IP. In the same way, we'll go to R1, show standby brief, and here we can see priority 110. Yes, we configured it. We set the priority 110 because we want to be R1, the active router. So state we can see active is local. Yes, this router is the active router. And standby is our R2. Here they given the IP address of R2. And we can see the virtual IP we set, that is a 10.10.10.1. Now we will configure HSRP in for this network 2. First of all, we will configure in R1 in this interface G0/0/1. So this is another HSRP we are going to configure here. So we will give some other group number. Interface G0/0/1. Standby version 2. Standby we will use here 2 as the group number. Then virtual IP 10.20.20.1. Okay. Standby 2. We will set the priority. We will give 110. Or we can give a 255, the last number. So here we can see from 0 to 255, we can set the priority value. Even we can set 255, the maximum priority. So he will become the active router. Standby 2 preempt. So we enabled the preemption. Next, we will go to R2 and we will configure interface G0/0/1. Configure terminal. Interface G0/0/1. Standby version 2. Standby 2 IP 10.20.20.1. Standby 2 preempt. Here we can see state change for this group 2. R2 is a standby and obviously R1 is the active router. We can verify that. Show standby brief. Here we can see group 2 default to priority and the state is standby. And here we can see the virtual IP we given and our active router is R1. So here is the address 20.2. Coming to R1. show standby brief. Here we can see group 2. We set the priority 255. So he is the active router. And we can see the virtual IP we given. So here R1 is the active router for network 1 and network 2, and R2 is the passive router for network 1 and network 2. We need to reassign the default gateway because we configured HSRP on both sides. So here in PC1, we will set the virtual IP we given, that is a 10.10.10.1. Then in this PC2, 10.20.20.1. We will test the connectivity. We'll go to simulation mode and we will see how it works. We are going to send a message from PC1 to PC2, and we can see it goes through S1 R1 through active router, S2 PC2, then coming back to PC1 through R1, because for this network also R1 is the active router, and we can see it's successful. Now we will go to real time and we will see what happens when this R1 goes down. Okay, we'll go to R1 and we will copy from run to start, and we are going to put off this router R1, active router. So we can see this path is closed. Just we will click on R2 and here we can see there's a state change. We can see G0/0/1 group 2 and group 1 standby changed to active. That means R2 become active router. So we can verify that. Show standby brief. And we can see now this R2 is the active router and standby is unknown because our R1 is down now. We will test the connectivity through simulation. We are going to send a message from PC1 to PC2 and we can see it goes to S1, and obviously this path is closed, but still our virtual IP is 10.10.10.1 only. That already we set here also, and this R2 become the active now. It goes through R2 again from PC2 to PC1 through R2. So it's successful. Back to real time and we will put on this R1 and we'll fast forward and click on this R1 CLI, and here we can see again R1 become active because we given preemption command, preempt. We can see group 1 R1 is active, group 2 R1 is active. Perfect. That's it for today's lab on configuring HSRP using IPv4 in a Cisco packet tracer. I hope this video helped you understand how gateway redundancy and failover work in real networks. Friends, if you found this video useful, don't forget to like, share and subscribe to our channel for more CCNA labs and other technical videos. Also hit the bell icon so you won't miss any my upcoming videos. Thanks for watching and we will meet again with the next video.